Hello, everyone. In this presentation, I'm going to talk about our accepted paper at SEMA, which is entitled Empirical Analysis of Security Vulnerabilities in Python Packages. My name is Mahmoud Alfadel. I'm a PhD student at Concordia University in Montreal, Canada. And this is joint work with Diego Elias Costa and my respected supervisor, Dr. Emad Shihab. Before I dig deep into our study, let me start by saying that the way how software applications are being developed today has changed. And this is due to what's called open source packages, where these packages are becoming more common and widely used in the applications. And here's one of the reports that showed around 80% of the code written in today's applications depend on these external packages. These packages are available from online repositories, which we call package managers. For example, NPM is the package manager for Node.js programs, PyPy is the package manager for Python packages, Maven for Java packages, and so on. Of course, these packages provide many benefits because they help software developers, for example, to reduce the time to deliver their tasks or time to market. So overall, packages boost the productivity of software developers. Unfortunately, it's not always good news because these packages may suffer from issues. One of the most pressing issues that affect these packages is security vulnerabilities in them. Here's a report that showed around 77% of around 400,000 JavaScript applications use at least one vulnerable package in them. More seriously, there was a very famous vulnerability called Heartbleed. Heartbleed vulnerability is a vulnerability that affected a package called OpenSSL. The issue in this vulnerability was that it allowed or authorized the memory access of software systems. And due to this vulnerability, many organizations, web applications, and softwares have been impacted. And the cost of the vulnerability and of that impact was estimated to be around 500 million USD dollar. And moreover, around 500,000 servers were affected by this vulnerability. What's also most important is that researchers in one of the studies found around 690 90 attempts of attacks were actually trying to exploit the Heartbleed vulnerability after its publication. So this means once the information about the vulnerability were available online and in the public, some attackers, they tried to utilize the vulnerability in order to exploit it. Given all this information and these figures, our goal was to investigate security vulnerabilities that affect these open source packages, and we focus in particular on Python packages that are available in PyPy ecosystem. And also we compare our results to another similar study conducted on Node.js packages called NPM packages by Decan et al. We conducted the several analyses by looking at different aspects. For example, we looked at how are these vulnerabilities distributed, how long does it take to discover these vulnerabilities, when are these vulnerabilities fixed, and how long does it take to fix them. We will look at this into more details down the track. Because before we conduct our analysis, we needed to collect some data set. And of course, the first thing that we need to collect is vulnerability reports of vulnerability reports that affect Python packages. We utilize the dataset available from Snyk. Snyk basically is a security company that monitors package vulnerabilities in different different software ecosystems and programming languages. This dataset is available in public, and utilizing this dataset, we're able to collect such information. For example, for each vulnerability, what's the type of the vulnerability, what are the affected, what's the affected package name, and the affected versions. What's also most important is the discovery and published date of these vulnerabilities. Also, it provides severity and fixed versions of the vulnerable package. Now, this information are very important and it's beneficial. However, it's missing some other information that we need for our later analysis. For example, here, the vulnerability report shows that versions less than 6.2.2 are vulnerable. However, we don't know what are the versions that are less than 6.2.2, and also what's the release date of these versions. And why we need this information? Because later on, when we, for example, analyze the discovery time, we need to know what are the versions, all versions affected, what's the first affected version, and what's the release date of that version. To collect this missing information, we utilize another public dataset called libraries.io that provides some package metadata information. And utilizing this dataset, we were able to collect for each package the version numbers of the package and the release date of each version. Overall, in our data set, we collected 550 vulnerability reports. These reports correspond to around 250 vulnerable packages. These packages contain around 12,000 package versions, but only 7,000 versions were affected by these vulnerabilities. Looking at our specs, in the first aspect, we looked at the vulnerability distributions in terms of different aspects. For example, the first thing we look at is the trends of vulnerabilities over time. So in this figure, we can see two lines. The blue line represents the number of vulnerable packages and their distribution over time, over years. And in the red one, we can see it represents the number of vulnerabilities or corresponding vulnerabilities in these packages over years. More specifically, if we look at this year here in 2012, there were actually only 27 vulnerable packages, Python packages by this year. However, just a few years later, in 2016, the number of vulnerable packages increased to 90 vulnerable packages, and this is almost 3 times the number found in 2012. So generally, we can observe a steady increase in the number of PyPy vulnerable packages and vulnerabilities. Of course, this might look like a negative indication because more and more vulnerabilities are appearing and are being detected. However, on the other side, this also might be might look positive because this means the community is dedicating more time and effort to find and detect vulnerabilities in these open source packages. Looking at NPM, NPM vulnerabilities actually followed a similar distribution where also the number of vulnerable NPM vulnerabilities and vulnerable packages were growing over time. And the next analysis and the next aspect, we looked at how long did it take to discover vulnerabilities. So we calculate the time it takes to discover these vulnerabilities with respect to the first affected version by this vulnerability. Looking at this figure, we can see that around half, 50%, so this is half of Python vulnerabilities, took around 36 months to be discovered. This is almost 3 years to discover PyPy vulnerabilities. Looking at NPM, NPM vulnerabilities are often discovered after 2 years, which is still a long time, but it's much less time than Python vulnerabilities. And probably this is due to the popularity of JavaScript programs because NPM became a prime target for attackers, which also may have contributed to a faster identification of vulnerabilities. In the next analysis, we looked at when are vulnerabilities fixed. So what does that mean? To understand this, let's here look at the life cycle of package vulnerabilities. So basically, and typically, package vulnerabilities goes into this life cycle. First, the vulnerability becomes introduced in the package, in one of the package versions. This is called the introduction time. After some time, someone finds the vulnerability or discovery. This is the discovery time. And finally, the information of the vulnerability become public online. This is called the publication time. And here actually the vulnerability has a higher risk because information has become public and more information about exploiting this vulnerability might also be available. Now the fix of these vulnerabilities may happen in different stages. For example, after the discovery time, software package maintainers, they start to work on a fix and they provide a fix here. However, we observe that sometimes the fix is only available after the publication, and also sometimes it's available before the discovery time or the reported discovery time, where we think that this is when software developers try to work in a private or a silence mode to provide a fix before they report the discovery of vulnerabilities. Taking all these stages into consideration for the vulnerability fix, what we found is that most of Python or PyPy package vulnerabilities, around 50%, 50.55% of these Python vulnerabilities are only fixed after the publication. So this gray bar represents the fix after publication. Generally, 50%, half of them are fixed after publication. Now, looking at NPM, interestingly, it's the opposite because majority of NPM vulnerabilities, around 80% of NPM vulnerabilities are fixed before the publication time. And such differences actually, when we dig deep and search about the reason behind this, we found that such differences can be attributed to the community, to the software ecosystem practices and policies for reporting and publishing vulnerabilities. For example, and for a fact, NPM has a very strict timeline after the discovery of vulnerability in order to provide a fix. Um, for example, NPM allows only 45 days for software package maintainers to provide a fix of a discovered vulnerability. Otherwise, the vulnerability becomes public, which is actually not the case of PyPy. Sometimes PyPy only publish the vulnerability right after its discovery. In the next analysis, we looked at how long does it take to fix vulnerabilities. And in this analysis, we look at vulnerabilities that have been discovered, and we look how long does it take since the discovery time, since these vulnerabilities were discovered, in order to fix them. In this figure, we can observe that around half of Python vulnerabilities, 50% of them, were only, they took around 4 months after the discovery time to be fixed. So generally for PyPy vulnerabilities, it takes 4 months after discovery time to fix them. However, looking at NPM vulnerabilities take almost only 1 month after discovery time to be fixed. And again, this might also be contributed to the community and ecosystem practices and policies for publishing, fixing vulnerabilities in them. To summarize our results, in this study, we looked at 4 aspects. We looked first at different vulnerability distributions from different point of view. For example, we found that for both NPM and PyPy package vulnerabilities, the number of vulnerabilities and vulnerable packages in both ecosystems are growing over time. In the next analysis, we look at how long does it take to discover these vulnerabilities, and we found for Python, it takes around 3 years to discover them. However, for NPM, it's a bit less than PyPy, which is 2 years. In the third analysis, we look at when are these vulnerabilities fixed, when a fixed version is provided or is released. And interestingly, the results were different from NPM to Python. So for Python, it was most of Python vulnerabilities were fixed only after publication. However, it's the opposite for NPM because most of NPM vulnerabilities were fixed before the publication. In the last analysis, we looked at how long does it take to fix these vulnerabilities after they discovered. And again, we found differences between NPM and Python. For Python, it was 4 months, and for NPM, it was only 1 month. Based on our result, we provide several implications, and here I will mention a couple of them. For example, we found that most of PyPy vulnerabilities are fixed only after the publication time, which is not the case of NPM, and therefore we believe that PyPy software ecosystem developers, they need the developer of PyPy ecosystem, they need to refine and revise the policies for reporting, publishing, and fixing vulnerabilities in the packages. Another example is that we found most PyPy vulnerabilities take around 4 months to be fixed after discovery, which is a bit long time. And again, this is not the case of NPM. And therefore, we believe that the PyPy ecosystem should provide and employ some tools in order to help developers be aware of of such vulnerable packages that take longer to be fixed in order to avoid using them, or maybe at least try to deal with them carefully. To conclude this talk, in this study, we investigate security vulnerabilities that affect PyPy packages or Python packages, and also we compare our result to NPM packages. Our result found similarities and divergences in some characteristics of the analyzed vulnerabilities. For example, in both ecosystems, vulnerabilities take a long time to be discovered. However, some divergences and differences, for example, was unlike NPM, the majority of Python or PyPy vulnerabilities were only fixed after being published or publicly announced. And such differences were attributed to specific policies of disclosing or publishing vulnerabilities in each ecosystem. By this, I conclude the presentation. Thank you so much.